Hello and welcome. My name is Hamza Ahmed, Technical Enablement Lead with Keysight. Today I'm going to take a few minutes to share insights in the challenges with XR device testing and how Keysight provides a solution for these. The future is now. XR devices are an emerging new category of device which offer the user an immersive experience combining views of both the real and virtual worlds. This new innovation is underpinned with a requirement to delight the user with the experience as they take their minds and body through to the virtual world. The user experience of these devices is influenced by many factors. For example, the headset's ability to track your head as it moves through 6 degrees of freedom. The usability of the UI, which can use gestures or combine additional controllers. Another example is the quality of any downloaded video and the impact of delays or packet loss in the wireless connection. And the last example is the delay from the headset moving to the rendering of the updated image, also known as motion to photon delay. So how do we test the user experience in such a way that we can make changes and compare the results? To address this challenge, we need to do two things. Firstly, automate the device so we can emulate a real user in a way that is repeatable. And number two, measure the KPIs which have a good correlation with what the users report in terms of perceived quality of experience. Using Eggplant alongside Keysight emulation and measurement capabilities makes it possible to test XR devices in a repeatable way and benchmark the user's quality of experience. This slide shows in a little more detail the challenges associated with XR user experience testing. Going from left to right, I'd like to briefly talk about each of these points and explain how Keysight Eggplant addresses each of these challenges. So number one, to test the user experience, we need to behave like a real user, a synthetic human if you like. With Eggplant, this is possible. It uses video capture to automate based on what the users see whilst using the headset. Furthermore, it has a model-based approach which makes it possible to build a digital twin of the user interface and interact at the functional level and not just at a pixel level. This allows you to automate user activity and then map that to different user profiles. Points number 2 and 3 is to automate multiple device types with complex user interaction. Extended reality is an emerging category of device, and each one has slightly different use models for how you interact with it. With Eggplant, you can accommodate these differences by using computer vision AI as a baseline for interacting with all of the devices. In addition, different interaction devices can be represented in the graphical user interface to complete the overall use model. Eggplant can then use computer vision AI to recognize either text or images on the display. Moving over to point 4, here we are adding the measurement of KPIs. This can either be pulled from the device itself, calculate in the automation environment, for example, video KPIs such as VMAF, PSNR, or SSIM, or can use Keysight equipment to make measurements of, for example, battery consumption or link quality, T-put, packet loss, latency, etc. Now point 5. In addition, we can add emulation and model different environments the headset may encounter. Keysight is able to emulate the cellular and Wi-Fi protocols as well as emulate the channel conditions. Finally, the Eggplant software can be used with a robot in order to emulate the movement of a synthetic human. This was too big to bring to the show, but we have a video here in which you can see that. Let me show a demo covering some of the points I have just mentioned. For this setup, I have an extended reality device connected via a Wi-Fi router, and the first thing I want to demo is the computer vision AI. The Eggplant environment is able to do optical character recognition as well as AI machine learning with supervised learning to recognize trained objects. This can be then included within your automation. As an example, we have trained the software to recognize a mug. Let me show you what happens when we bring a mug into the view. For the second part of the demo, we are showing a simple way in which KPIs can be accessed. Here we are downloading a video and pulling KPI info from the video into the Eggplant environment. Finally, let me show you a video which demonstrates Eggplant controlling a robot alongside a vision-based automation environment.